All right, let's run through another example here. Page 563, we've got some problems dealing with drawing a card out of a deck. It says standard deck of cards is 52 cards. Most of you probably know there's 4 suits, a heart, diamond, spade, and clubs. 13 cards in each suit. The 13 cards include an ace, a king, a queen, a jack, and then the numbers 10 through 2. If one card is drawn from the deck, just one, find the probability of each event. Okay, so remember with probabilities, you want the number of ways that it can be done, the number of outcomes in the event divided by the number of total outcomes. Okay, so if you think about it, in the sample space, there are 52 outcomes in the sample space, because any of the 52 cards could be the one chosen. Okay, so that's the first thing to keep in mind. And then but only one can be chosen. Okay, so when we look at the probabilities here, let's see, the first one says the card is an ace. Well, how many possible aces are there? So in this first one, in 33, the event is that you would get the ace of heart, or the ace of diamond, or the ace of spades. Let's see if I can draw all these, something like that, or the ace of club. It's like a 3-leaf clovery thing. Right, so those are the 4 options. And so the outcomes in the event are 4, the outcomes in the sample space are 52. So our probability then, the probability of an ace is equal to the 4 aces divided by the 52 cards. It's the number of outcomes in the event divided by the number of total outcomes in the sample space. And of course 4 over 52 does reduce down to 1/13 if you divide both of those numbers by 4. And so 1/13 is the probability. We always want to reduce our fractions down if possible. Okay, so you have 1 in 13 chance of getting an ace. Alright, so if you look at number, I'll go across the top here to 37. What's the probability of that the card is the king of hearts? Now that is a particular outcome, right? The event then, the event is just a king of hearts. That's it. There's only one option in there. And so the probability of the king of hearts would be 1 out of 52. That's a 1 in 52 chance. A fairly low probability. Okay. Let's look at 34 here. Let's say the card is a 1. What? What is a card that's a 1? That's an interesting one. Well, there is no such thing as a 1 card. You could say it's the ace, but that's not what they're getting at. They're trying to get at a card that's not an actual card. Because there is no card 1, the event is the empty set. There is nothing in the event. There is no card 1. And so the probability of getting a 1 is 0 out of 52. Or 0. There's a 0% chance, a 0 probability that you'll get a 1 as your card. Okay. Let's jump down to number 35. Oops. Handwriting's getting terrible here. 35 says the card is a club. Okay, so the event would contain anywhere from the ace of clubs. I gotta draw clubs. Oh my goodness. Okay. The ace of clubs the king of clubs, the queen of clubs, the jack, da da da, all the way down to the 2 of clubs. Okay, so I'm not going to write all of them out, but there are 13 events in there, or I'm sorry, 13 outcomes. I'll move this up here. 13 outcomes, because there are 13 cards in each suit. All right, so the probability of getting a club is equal to 13 out of 52. Now 13 out of 52 does reduce, both are divisible by 13, and you would end up with a 1/4 probability. Okay, 1 out of 4. Remember, 4 times 13 is 52. That's how you get 52 cards in a deck. Okay. All right. And then let's look at maybe 39 as our last one here. So 39 says the card is a queen or a jack. Okay, so there's really 8 different options. So event, you could have a queen of heart, queen of diamond, queen of spades, or queen of club. Or you could have the jack of heart, jack of diamond, jack of spades, or the jack of clubs. And so it turns out there are 8 different outcomes in that event. Okay, and so the probability of that occurring, probability of a queen or jack, would be 8 out of 52. Now 8 out of 52, those are both divisible by 4, right? So if I divide 8 by 4, I get a 2, and if I divide 52 by 4, I get 13. That doesn't reduce further, so 2/13 would be the probability. All right, so that gives you some idea of how to calculate these probabilities. Again, remember that a probability is the number of outcomes in the event divided by the total number of outcomes in the sample space.